Lesson 7-6, Multiplying Polynomials. At this point we have multiplied and divided monomials, but now we're going to work on multiplying polynomials, which includes binomials, trinomials, and just general polynomials with any number of terms. Multiplying polynomials is applying distribution with more variables and more terms. So we're going to multiply a monomial by a polynomial, then we'll multiply two binomials, a binomial times a trinomial, two trinomials, and then we'll talk about the process you can use to multiply any size polynomials. We can multiply using two methods, FOIL and a table. And we'll go over them both in details, and they both provide the same results, so choosing the method is up to you and your own personal preferences. So multiplying a polynomial by a monomial is just a straight distribution. We distribute the monomial. So we multiply each term in the parentheses, here and here. So 3 times 4x gives us 12x, and 3 times negative 5 gives us negative 15. If we have a variable, that's fine. We multiply that in as well. So I have 2x times 5x, which gives me 10x squared, 2x times 4y, which gives me 8xy, and 2x times negative 3 gives me negative 6x. If we have multiple variables, we multiply each part by its alike part. So when I do this multiplication and I distribute in, I'm going to have 3 times 2, which gives me 6, a squared times a, which will give me a to the third, b times b squared, so b to the third, c to the third times c, which gives me c to the fourth, then 3 times 10, which gives me 30, a squared times a, which gives me a to the third, b times b, giving me b squared, and c to the third times c to the fourth, giving me c to the seventh, and then 3 times negative 4, which gives me negative 12, a squared times a, which gives me a to the third, and b times b, which gives me b squared. C times nothing, so I just keep it as c to the third. And we need to be sure, if we are multiplying with a negative outside, that we multiply by a negative. So I have negative 5 times 13, which will give me negative 65, x times x, which is x squared, y times y, which is y squared, z, you can't leave those behind, negative 5 times negative 10 to give me positive 50, x times x squared gives me x to the third, y times y to the third gives me y to the fourth, z times z gives me z squared, and then negative 5 times 18 will give me negative 90. And then since there are no variables on the 18, I just copy the same variables on the monomial from the outside, x, y, and z. Okay. When we multiply two binomials, there are two methods we can use, the FOIL method or the table method. FOIL is an acronym that gives us the order in which we multiply the terms in the binomials. FOIL stands for first. Those are the first terms in the parentheses. Outside. These are the two terms on the outside of the parentheses. Inside. These are the two terms on the inside of the parentheses. And last. These are the two terms at the end of the parentheses. When we multiply binomials, again, we have the FOIL method or the table method. Using the FOIL method, I'm going to multiply 2x times 3x to give me 6x squared. 2x times negative 6, which will give me negative 12x. So first, outside, inside, so 4 times 3x is give me 12x. And then last, 4 times negative 6, which gives me negative 24. Then I combine my like terms. So I'll have 6x squared minus 24 because the negative 12 and the positive 12 cancel each other out. Using a table method, multiplying the same binomials, what I do is I create a table and I list the terms one polynomial down, one polynomial across. So 2x plus 4, 3x minus 6. I add boxes in between each of the terms, and this works the same way a multiplication table works. So when we use a multiplication table, you multiply this by this to fill this box. So 2x times 3x gives me 6x squared. 2x times negative 6 gives me negative 12x. 4 times 3x gives me 12x. And 4 times 6 gives me negative 24. When we use the table, our like terms will show up in a diagonal pattern. So our like terms will be on the diagonals. The top left-hand corner will be our first term. We'll add our like terms in the middle, so 12x minus 12x is 0. And then our last term will be in the bottom right-hand corner. So as you can see, you get the same result no matter which method you use. It's just a matter of preference, whether you would prefer to use the FOIL method or the table method. Oh, and I ran out of room, didn't I? Sure did. Let me fix that. There. Put that over there. Okay, so using FOIL method, first gives me 15y squared. Outside gives me negative 30y. Inside gives me negative 10y. And last gives me positive 20. Collecting my like terms, I will get 15y squared minus 40y plus 20. Or using a table, I have 3y minus 2, 5y minus 10. 3y and 5y is 15y squared. 3y and negative 10 is negative 30y. Negative 2 and 5y is negative 10y. Negative 2 and negative 10 is 20. My like terms show up on my diagonals, so I get 15y squared minus 40y plus 20. So again, we get the same result, it's a matter of preference. Now when we multiply a binomial times a trinomial, we have to use a modified FOIL because we can no longer use the first outside, inside, last. Or we can use the table. Now on the modified FOIL, you multiply each term in the first, multiply okay, so I'm going to end up with 2x times 4x squared, which will give me 8x to the third, 2x times negative 3x, which will give me negative 6x squared, 2x times 5, which will give me 10x. Then I come and do the second term. 3 times 4x squared gives me 12x squared. 3 times negative 3x gives me negative 9x. And 3 times 5 gives me 15. Combining like terms, I have negative 6x and positive 12x. First I write down my 8x to the third. Negative 6 plus 12 is 6. Then I have 10x and negative 9x, so that gives me 1x and then a 15. Now when you do a modified FOIL, your like terms are no longer right next to each other. They could be sort of missed around in here, so you'll have to look for them. Also, as you get into more terms, a binomial times a trinomial is not so hard to keep track of, but as we get into trinomial times trinomial, and then if you get into even bigger polynomials, the modified FOIL method can become very cumbersome and difficult to make sure you don't miss any multiplications. The table, however, stays very sort of compact, and it's pretty obvious if you've missed anything, because what will happen is since you're creating a box for each multiplication, if you forget a multiplication, say for example I forget to multiply 2x times negative 3x, it becomes very apparent because you have a blank space. And you say, okay, I missed that one, so then you can come in and multiply. Again, our like terms will show up on the diagonals. So I have 8x to the third, 12 minus 6 is 6x squared, negative 9 and 10 is 1x, and then the 15. So when you get to the larger polynomials, sometimes the table method is preferable because it keeps everything neat and makes it harder to lose track. Let's try a couple more. Modified FOIL, 2x times 3x is 6x to the third, 2x times 5x is 10x squared, 2x times negative 10 is negative 20x, negative 5 times 3x squared gives me negative 15x squared, negative 5 times 5x is negative 25x, and negative 5 times negative 10 is 50. 10x squared and negative 15x squared gives me negative 5x squared. Negative 20x and negative 25x gives me negative 45x, and then 50. Using the table, I write each polynomial across the top and down the side. I'm going to get all of the same multiplications. It's just in a more sort of organized fashion, I think. So 6x to the third, my like terms are on the diagonal. What I would like you to do is I would like you to go ahead and pause the video and try these two. Try this one using either the FOIL or the table, or you can try both. See which one you like best, and then come back and check your answers. Okay, so no matter which method you tried, you should have gotten 20x to the third minus 70x squared minus 80x plus 55. Double check and make sure all your multiplication is correct if you did not get that answer, and then make sure you added correctly. Those are usually the two areas where mistakes are made. Okay, multiplying two trinomials. Here's where we start to get a little bit complicated with the modified FOIL. So I'm just going to show the lines. I'm going to have to multiply these three here, then these three, then these three. And you can see how the lines get kind of mixed up in here. It can be kind of hard to keep track. So first, 3x squared times 2x squared gives me 6x to the fourth. 3x squared times negative 5x is negative 15x to the third. 3x squared times 13 is 39x squared. 4x squared times 2x squared is 8x to the third. 4x squared times negative 5x is negative 20x squared. 4x times 13 is 52x. And I'm going to have to move down because I'm running out of space. Negative 10 times 2x squared is negative 20x squared. Negative 10 times negative 5x is 50x. And negative 10 times 13 is negative 130. Now I combine my like terms. Negative 15x to the third and 8x to the third gives me negative 7x to the third. I have 39, negative 20, and negative 20x squared, so that gives me negative x squared, because 39 minus 20 is negative 19, or sorry, 19, positive 19, minus 20 is negative 1. Then I have 52 and 50, so plus 102x minus 130. With the table, it's the same process. No matter what size polynomial you have, you just end up with more rows and columns. So 6x to the fourth, negative 15x to the third, 39x squared, 8x to the third, negative 20x squared, 52x, negative 20x squared, 50x, and negative 130. Our like terms are on diagonals still. So 6x to the fourth, 8x to the third, and negative 15x to the third, negative 20, and positive 39, 50 and 52, and then the negative 130. Okay, so now I would like you to go ahead and try each of these. Now we've done up to 2 trinomials. The process will be the same no matter how many terms you have. If we have a trinomial times a polynomial with 4 terms, we can still use this modified FOIL or the table. Just remember, with each FOIL method, you have to multiply every term in the first by every term in the last. So you'll have a lot of multiplication lines to keep track of. With the table, you just add extra rows and extra columns depending on how many terms you have. So go ahead and pause, try this problem. It's the same problem. You can use either method or both, and then come back and check your answers. Okay, check your answers. And if you did not get the same answer I did, check your multiplication first, and then your addition, and make sure you didn't miss multiplying any terms if you used the modified FOIL.